Hello, everybody, and welcome to the 28th episode of TechLifeSkills with Tanmay. My name is Tanmay Bakshi. Thank you very much for joining me today. And a couple of days ago, I was watching the Apple event, and I'm sure a lot of us were. And personally, I've got to say that I was really intrigued as to just how much of their presentation was dedicated to the inclusion of 5G in their new phones. It was one of their, highlight things in the entire keynote. And personally for me, it raised a lot of questions in my mind as to what exactly the relevance and the significance of 5G technology is in our lives. Why should we care about it? What kind of value is it going to add? What kind of capabilities is it going to unlock? And I was also thinking that today's episode of Tech Life Skills has been perfectly positioned because that's exactly what we're going to be diving really deep into today. We're being joined by a very special guest. His name is Peter Linder, the head of 5G marketing for North America at Ericsson. Now, one of the reasons I'm so excited to have Peter on the show is because he has so much experience with this stuff. I mean, he's been with Ericsson for over 10,000 days. So that's a lot of time to spend, concentrating on this one field, this one industry. His 30 years of experience, 10,000 days, is something that I'm sure we're all going to be deriving a lot of insight from. And, of course, we're going to be talking about the challenges that he's facing staying current in not just the field of 5G networking, but also digital marketing. So this is going to be a really fun discussion. And without any further ado, I'd now love to welcome Peter to the show. Hi, Peter. How are you?
I'm fantastic, Tanmay. Thank you for inviting me here. It's great to be here because, as you said, I've been working quite a field in the broadband industry, but I think I've never been so excited as I'm right now as what 5G is going to bring. Because the previous generation, I think, has been brought a little bit here and there, and each generation has been a big step forward. But what I see with 5G is something significantly broader.
Absolutely. I totally agree, right? There's those steps that we've seen in the past that have enabled all sorts of new capabilities, but I feel like this step is even larger and it's going to enable all sorts of things, especially with other technologies that are coming out, ones that are more data centric, ones that are more cloud centric, ones that need more compute, that are going to enable us to do all sorts of different things. But before we get into that technology, I'd love to sort of learn a little bit more about you. Would you like to quickly maybe introduce yourself, tell us a little bit about the work that you do, how you got here?
Yeah, absolutely. So I'm living in Texas right now. I'm heading up 5G marketing and also 5G evangelist for Ericsson. This evangelist journey is a journey that started 9 years ago when we had a vision. We started to work with a vision back then to talk about the network society and what that could mean. And we figured out that we need to talk to a lot of other companies and other people outside the telecom industry. So for 9 years, I've been doing this evangelizing about all different kinds. If you go back a little bit further, you can say that from 2006 up until now, I've been focused on mobile broadband, and that's when pretty much 2006 was when we started to say, hey, we can do 1.8 megabits of data to a phone. This is going to be broadband. So there is a piece of mobile broadband that I've been working with, and before that. You can say between 1993 and 2006, I was working with fixed broadband in various different shape and form, from the very first stages of 2 megabits on DSL, which we thought was fantastic, to the cable technologies and fixed wireless technologies that existed back then. So I think you can describe me a little bit as a broadband networker in that perspective. Spent roughly half of my career in the United States and half in Sweden, and when you're working for a Swedish company like Ericsson, being in Sweden essentially means you're traveling all the time. So during that journey, I've had the opportunity to visit 202 different airports in the world, and it's something that I think have helped building a little bit an understanding for cultural differences, and that things that work broadband-wise in one country doesn't necessarily work in another country. So this I've got a deep respect for the impact of culture in all of this. Before I joined Ericsson, I went to Chalmers University in Gothenburg. I studied electrical engineering and also had a master's degree in business administration. And before that, I lived in the town where I grew up, which is a very small town. We don't have any traffic lights, we don't have a high school, but we have a Formula One racetrack. in this town with 5,000 people. So racing shaped a lot of my life. When I was started first grade, I was trying to convince the teacher that we should start early with English so we could speak with the Formula One teams. I was walking around in the paddock with the full credentials from age 8. And my first English words were, "May I have some stickers?" And I also was very involved in the timekeeping. My father was chief timekeeper back then. And that was quite as advanced as technologies could get back then when we started with digitized timekeeping of Formula One races in '73. And then in the later half of the '80s, I was chief timekeeper for what today is MotoGP, motorcycle races. So I kind of racing is a lot in my life. So I guess that speed translated into broadband networks in a professional career. That's perhaps a little bit who I am.
Wonderful to hear. I mean, first of all, it's fascinating to think that so much of your life has been shaped by the world of racing, and I feel like it is definitely a fitting theme. Speed in racing, and you're so passionate about speed in networking and communications now. I feel like that is a fitting parallel. And one more thing that I really appreciate about what you said that I feel like again not enough people concentrate on is that culture aspect, right? Because if you think about it, the internet and generally the reason it exists is to connect people across the globe, right? It's meant to enable us all to be able to communicate with each other, to share ideas, to talk to each other instantly, internationally, no matter where you are in the world. And unless we can design not only the internet but also the infrastructure backing it to be something that works across the world, across all these different cultures and what they accept, I don't think it's going to work unless we're able to do that. We're not going to be able to achieve that goal. So I really appreciate what you said about that. Now, I do see already there are a couple of questions coming in from the live stream chat. Akash is talking about, how is 5G going to be relevant to other technologies and so on. We will be getting to that in just a moment. But first, though, Peter, there's something that I'm wondering that I wanted to ask you first. And that is about 5G more generally, and this is something that back when I first heard of it a couple of years ago, not a couple of years ago, last year, back when I first heard of 5G, it was like, all right, so it's the next generation of mobile network access, right? It's how much better exactly is 5G when compared to 4G LTE, what we already have out there as the standard today? What sort of new capabilities does 5G unlock for us? And how big of a leap is it really?
Yeah, no, I think that the best way to understand, I start with the different leaps here, and then I come to the capabilities. I think the first, when you look at the mobile technologies, it's important to think about, okay, the best way to try to understand the magnitude of what 5G does is to look backwards a little bit, see what does each of the first generation meant. So when 1G was introduced, I was an inside salesperson at a small company in my hometown, and it was really, really hard because 8 o'clock every morning, as soon as I stepped into the office, all the 6 sales guys were calling from different parts of the country with all the orders they had gotten the day before. And they had to make those calls between 8 and 9 before they went onto the road, because they called from a fixed phone in the hotel back to the office. They were the first people that I saw that got cell phones, which it was half a suitcase in the car. But all of a sudden, they could call in the orders immediately as soon as they got it. So when they stepped out of the customer, first thing they did was they picked up the phone, called me and said, "Hey, Peter, I got this order here. Can you make sure that it goes out tomorrow?" So we cut out the day in lead time there. And my mornings between 8 and 9 was totally different after that. When the first 1G phone came, which was like sitting in the trunk of a car. The next one came with 2G, and then everybody said, well, I had a debate with my dad. He said, well, this is total waste. All phone calls can wait until you get home. And if you want to send short messages, you can send a postcard. But I tried to explain, no, but when we have the pockets in our phones, we can make short calls here and there. We can make adjustments, and I think the big thing with 2G was very much that the phone got into a pocket, and also the affordability got so everybody could use it. So we created a totally different way of communicating. And this short messages started becoming, say, hey, should we meet at 7 o'clock? Yeah, 10 minutes late. Okay, good, I know. So it started to become we became a little bit more sloppier in our planning, but we started to take advantage of the technology. And then when 3G came, I think we were very wrong at our end because it's hard to predict. We were betting on mobile internet. It's going to be fantastic. We're going to get a whole internet in 20 characters on a window, and video telephony. We talked about everybody's going to do video telephony. None of that happened. But with 3G, we start to see that the phone became very much the collection point for all other things we had. The music player went there, the camera went there, and a whole bunch of things. The calendar went there, and all different things started to get integrated. And the reason why I could do that was that we had a data connectivity to the network. And then when 4G, I was in charge of the 4G solution portfolio back when we introduced 4G. And very close before the launch, we were still planning for 90% laptops and 10% smartphones when we looked at the potential for 4G. The reason for that, we saw that there was no way a smartphone could consume all that capacity that we were unlocking with 4G. So I think that my message for these first four different generation here is that each leap has been very big. And now, but it has been hard to predict exactly what it's going to be. No one could predict Uber and things like that back when we invented 4G. So what makes 5G exciting to me, it's that we have approached 5G in a different way. So wherever we had to make choices for 4G, we had done both for 5G. So 4G was very much made for consumers. Consumers in a smartphone, and we brought the phone to work, but it was very focused on the consumers. 5G is focused on consumer and business. The second thing is that 4G was very much focused on mobile applications and mobile. And then all mobile technology generation are driving fixed wireless at some point. But now for 5G, fixed wireless access, so the ability to do broadband, fixed home broadband in the air is as important as the mobile piece. And the third piece is, if you look a little bit, it's like most cellular network today is widely available for everything. So a public network with everybody use. 5G we started to apply that for private network. So business can deploy 5G at their premises for certain purposes. In our brand new 5G factory here in Texas, we put in a 5G network in that factory for some things that we're doing. We've also done the same thing at our corporate headquarters here in Dallas to create innovations. And what we hope to be able to tag into and unlock, there's a number of different things that 5G does better than any previous generation. When we look at speed, we're increasing the speed for the traffic from the network to you and me as a user. What we can do with that speed, essentially, we can provide more video. And video is playing an essential role in the evolution of 5G. Because around 3/4 of the traffic, if we go out 5 years, and the network is going to be video related. The second thing is that we increase the capacity upstream in the network. Upstream, that means from your device to the cloud. So when you're sending information in forms of data points or videos or capturing certain things that's going on, and that goes up to the network. I'll give you one example here. What we did with Indy, you're going to get a lot of racing examples here. But at IndyCar, at the practice for Indy 500 last year, there's always this that you put cameras on top of the roof and see how the drivers are driving. And since they're driving at 220, 230 miles per hour, it's like a feet up or down, or exactly track positioning is important. So those videos were analyzed with artificial intelligence. So you essentially film during the day, you send them down, it's analyzed, and then the morning after you tell driver so-and-so that, hey, in corner number 3, you're a little bit too high up on lap number 37. And it's kind of interesting, but it's hard to take action. If you connect that camera with 5G, send it down, analyze immediately, you can send out, hey, on the previous lap in turn 3, you're a little bit too low, you should go a little bit higher. So these kind of things with when video goes the other way. The other thing is perhaps the second most important thing with 5G is about latency. And if you don't understand what latency is, you can talk to Madam A, or the lady that's in the back here, which will go off if I start talking to her. her name starts with an A. You ask her a question, and the latency is the time it takes from when you ask the question until you get an answer back. So for 5G, we're going to try to reduce that latency, because otherwise you can run into a problem if you apply this for latency sensitive application. For example, anything where you need really rapid responses. So we're reducing the latency in the network itself with 5G, and we're also driving with that, we're pulling a lot of the cloud computing capabilities with us out to the edge. So there becomes a lot shorter distances from where the computing is in the cloud to where our device is, which allow us to create completely new applications. We're doing other cool stuff. We are allowing 10 times as many devices in each and every geographical area. And that is important because it's not only your phone any longer, it's phone and a bunch of other things. So to enable the whole IoT evolution, we're increasing the precision accuracy. So today you can, with your phone, with GPS and Wi-Fi, you can just say, hey, I'm here and here. You want to go over and have a coffee here, follow the map, and you go on the outside. It works fine outside when you see the satellites. But with 5G, we're starting to be actually being able to determine where you are and your devices are from the network. So without having access to GPS, and where is that relevant? It's relevant when you're indoors. And if you're a drone flying around indoors, you need to know a little bit where you are, and especially if you're going to get new maps and things like that. So I would describe, we're currently debating how we best describe these different, all these different attributes, but it has more to do like a chess game with different types of pieces that you have at your disposal that you can play with. So that's perhaps, it's not the comprehensive, but I think you'll get a feel for where it's changing. And it's, in my world, it's a significantly bigger change than any of the 4 generation shifts before.
Absolutely. I can absolutely see that because, I mean, first of all, one thing that I want to say is that the first thing that comes to anybody's mind, I think, when they hear 5G first, is that, oh, so everything's going to be faster now, right? And I feel like that's really, really underplaying the potential of 5G technology. Because if you think about what 5G is, I think it's really the infrastructure that enables a lot of great things to happen on top of it. It's not, I mean, first of all, it in itself is great technological innovation, but it itself builds infrastructure that's going to enable a lot more innovation in terms of actual use cases and actual products building on top of it, right? People don't really give technology infrastructure enough credit. You know, for example, when it comes to 5G, you might think, oh, so now if I'm on my phone outside and I'm connected to a 5G network, you know, maybe I can download a Netflix show really quickly because, you know, I've got this super fast 5G connection. But what you've got to think about are new use cases that could not have been possible without the power of a 5G network on your phone or on a mobile device or on an edge device, right? Those are the sorts of things that we need to think about. I feel like maybe one of my favorite examples, actually, and this is actually pretty funny, is if you take a look behind every Apple operating system, there's of course the Darwin operating system, which is that sort of Unix core combination of a bunch of different, the Mach kernel, BSD and stuff. And you take a look at the phone, the HomePod, the watch, TV, everything is powered by that Darwin operating system, just modified to be specific to that device. Now, one thing you might not know is also powered by Darwin is the little dongle that plugs into your phone to go from Lightning to HDMI. That's just a dongle. You'd say, why does a dongle need an entire operating system on it? Well, the Lightning port actually doesn't have enough bandwidth to transfer the full resolution of the iPhone display through HDMI. So what they do is they actually put a CPU in the dongle, and every time you plug it in, your phone flashes a Darwin firmware onto the dongle, and then the dongle actually uses that chip to encode the video coming out from your phone and send it through HDMI. And as a consumer, you never need to think about it. You plug it into your phone, you plug it into your TV or a monitor or whatever, and it just works. But without that incredible technology infrastructure, the ARM chip that's in the dongle, without the Darwin operating system to do the encoding, that wouldn't have been possible, right? So it's little things like this that add up to enable amazing user experiences. And when it comes to 5G, not only do we have this capability of being able to send a massive amount of data or have really low latency connections, or I mean, those technically go hand in hand, but we have this capability now that developers have this whole new tool in their toolbox to use to solve problems that previously might not have been able to be solved because, well, we didn't have the right tool for the job. So while existing use cases are definitely going to get better, I feel like the real value is in what we can enable that's new. Maybe a good example, actually, maybe sort of almost proving that point, would be, with the latest iteration on the iPhones. What iOS will do is it'll detect if you're not really using 5G and you don't need that incredible speed, it'll automatically go back to 4G and LTE just to save battery. And I think that's an incredible example because when you do need 5G technology, that's something that can automatically kick in. But when you don't really need all that extra power, right? So I feel like that's definitely something that we should start thinking about, right? What else can we do now that we have this technology at our disposal? As a matter of fact, speaking of this new technology, we are getting 2 questions from the live stream, and this is something that I'm very sort of interested in as well. So I do want to ask you that now. This question's coming in from both Akash and Thierry. They're slightly different, but I'm going to sort of group them into the same category of question. Akash is asking, is IoT going to be the most benefited from 5G technology? So is the IoT field going to be the one that's most benefited? And Thierry is asking, is 5G causing a revolution in edge computing? And if so, can we start to think about peer-to-peer again as a viable alternative to a centralized system? So 2 similar questions. Let's go ahead and answer Thierry's first. So is 5G causing a revolution in edge computing? And can we start thinking about peer-to-peer again instead of centralized systems?
Yeah, I think that very good question there. I think you're saying 5G. It's not so much if you compare it to 4G, there was essentially three revolutions. It was the smartphone and how that developed. It was the capabilities of the 4G network, how that developed, and then the cloud and the applications residing there. If you look at 5G, it's a little bit more complex landscape. So you got 5G, which is changing what's happening in the air interface in the radio. You got edge computing, we're pushing down the cloud very close to subscribers. You got IoT, where the types of devices are exploding both upwards and downwards. So we can connect anything from a small sensor in the vineyard to a drone flying around, where we have to have coverage up in the air, not only along the streets. And then you have artificial intelligence that we're both going to serve, and we need to use artificial intelligence extensively in the network. And you got augmented and virtual reality that today is very hooked up to wired to a computer. So I think that you're right in the sense that with a lot of the development that's happening with edge and 5G goes hand in hand. And I think what I see is that going to trigger a not only peer-to-peer application, but a broader transition where you can take compute off devices. You can take compute, memory, and power off a device and put that in the edge, so that the devices become lighter, cheaper, and with longer battery life. I think that is a very important aspect of the whole. The other question here regarding IoT, I see 6 different broad categories of use cases when I'm looking at 5G. First, the foundation, which is enhanced mobile broadband, which is going to smartphones and the likes. Fixed wireless access, which is connecting homes and small businesses, doesn't move. And then on top, we have 4 different IoT categories that ranging from either very small devices, little traffic, long battery life, or broadband IoT, which is more like if you think about your smartwatch, we're taking the 4G technology, put into another device with lower price point, not crazy data volumes. And then we've got 2 new ones that come in: critical IoT, which is where the latency is critical, the bandwidth is critical, reliability is critical. And the 4th one is when we're applying it in industrial settings for industry automation IoT, where you can essentially say 5G is a way of combining the best of wires and Wi-Fi. So it's got the reliability and the performance of a wire, but the flexibility of Wi-Fi. You're putting those 2 together, you can create a lot of flexibility in the production environment.
Mm-hmm. So one thing that I just thought about when you said that was I'm not sure how long ago this was. This was a couple of weeks ago, actually. And I was, we had on the show two experts in the world of AI and machine learning. They were executives at IBM Research. I'm forgetting if this was Ruchi or Sriram that said this. But they said that within the world of machine learning, right? Data has a lot more weight than algorithms. Data has a lot more gravity than the algorithms. So what we always want to do is we want to move the compute and the different techniques and stuff closer to the data rather than the other way around because that's easier. And I feel like when it comes to machine learning, we've almost been forced to put the algorithms near the data again, in the sense that you look at phones today, a large portion of the chips are actually dedicated just to machine learning acceleration. Because, like, for example, the Face ID on the iPhone and these sorts of things couldn't have been possible without that acceleration, right? And I mean, this sort of goes to show, even with the new A14 Bionic, which is the first sort of 5 nanometer process chip, a lot of the 40% of new transistors that they included in the phone went to the neural engine to double the number of cores and go from 5 billion to 11 billion operations a second. And what I think that goes to show is that technologies like AI and machine learning are important enough to dedicate literal silicon space to it rather than to the general purpose CPU or anything else. And with 5G, what I appreciate about what you said, Peter, is that we can sort of make the cloud in a way closer to these edge devices. And I mean, in this case, I'm just using the analogy of a smartphone since that's what I feel like we can most relate to. But in general, edge devices can now be almost physically closer to the cloud and start to leverage more of the compute and the capabilities that we have on the cloud while still producing that data, en masse on the edge. There's so many capabilities, so many things that we couldn't have done without that new capability. So I thank you for that, and of course, if you have any sort of follow-up questions, Thierry or Akash, please feel free to put them in the live chat, and we'll definitely be getting to those as well.
I will take you up on that one, because I think one good example I've seen on this is if you look at like how surveillance cameras worked in the past, you were looking at seeing what was going on, you were recording it, and then when bad things had happened, you kind of sort of could go back and figuring out what went wrong. But you never prevented bad things from happening, but you could sort of understand afterwards why they happened. If you now fast forward into this new world, you're saying you can have a camera that is looking at things what is going on, and then it's kind of say, hey, bad things is about to happen here. We need to alert A and B so that bad things doesn't happen. And give them a signal and a trigger. It's like preventing a burglary or preventing two people from crashing into each other, something like that. But if you're looking at all the video generated in the meanwhile, like just, hey, nothing is happening. Nothing happened now neither. There's still nothing happening. That video, you can take that, analyze, and the sooner and closer to the source you can throw away all the stuff that used to be meaningless, because we're going to connect so much meaningless data in this world. We have to collect it so that we can sort out the important ones, but all the others, we're better off throwing it off. And that is typically one of the jobs that's going to happen at the edge.
You're right. I feel like there's so much capability that we haven't been able to unlock just because we haven't had that access yet. I mean, personally, there have been many projects of mine, right, that I'll be working on. And one of my favorite examples, actually, is around being able to understand electroencephalogram data in real time. That's very compute intensive. We're getting many channels of data. We're getting this over 1,000 times a second. That's way too much to be able to send to the cloud in real time, analyze, and bring back. That was not possible before. You would have to have had, an entire computing cluster available with you locally to be able to process that data with the kinds of algorithms that I'm using, in order to have any sort of useful application. But nowadays, with 5G technology, this kind of innovation, these sorts of use cases are becoming possible. So I'm really excited to see what kind of doors we can unlock with that. Now, we've already talked a little bit about IoT and edge and AI, but I sort of wanted to generalize a bit more. Could you maybe tell us a bit more about how 5G actually relates to all these different fields and technologies, and how exactly does 5G sort of tie in with other major technology innovations?
Yeah, so I think that the first one is like if you take about 5G itself, there's a couple of things that is changing. The first one you could say, 4G was very much, we used the same spectrum across 4G, pretty much homogeneous spectrum in the middle. If you describe 4G to a golfer, you describe it as like playing around the golf with the 4-iron for all your shots. And that what we do with 5G is we're expanding the spectrum both upwards and downwards, so that we have spectrum that reach further out, longer, like a driver, and we have spectrum that reach shorter but with higher precision, which is like a wedge. And if you're not a golfer, this is like moving from being a runner to being a triathlete, where all of a sudden you should do biking and swimming as well, and not just the running piece. So there's a number of different ways that 5G in itself are changing. We're also changing quite a bit of the topology in the 5G network. So things before that was very simple. There was things that was in a tower, and there were things that were fibers feeding the towers, and then we had the core network at the 5G network at the other end. What we're doing right now, we started moving some of the radios, we're moving way closer to subscribers, putting them on a pole, putting them in the building or something like that as a complement to the towers. We are using both fibers and wireless technology in terms of feeding those towers, because there's going to be so many more of them. And we are centralizing some of the radio functionality, so it's becoming sitting very close to where the core functionality was, and that's also where we're bringing the edge functionality. So there's a number of different shifts, and perhaps the biggest shift in the 5G networks, we used to create a software load once or twice a year that we upgraded the network with, and we say, hey, it's coming a new phone. Oh, it's coming a new phone. Let's do a new software load. So we did those software loads were coming like in 6 or 12-month increments. But now we're speeding up that process, so it's becoming a lot more frequent. So for some customers, we do it every month. Others, we do it 2 weeks, and we have customers that have taken new software loads daily. So there's the network in itself is becoming like a kind of a platform, 5G network, like kind of a platform that moves at least as fast as you and I upgrade operating system on our phones. If we then move, I think, to the edge, the edge is very tied to this, and I see a lot of what's going on at the edge is bringing that compute capabilities closer to the customer, not for every single service. So when you think about the future here, the cloud computing capabilities for small sensors that watching a farmer's farmland, they might be highly centralized. Other part of the edge compute, which is related to critical IoT, performance critical application, they're very close to the subscribers. And in some cases, like for a business, like our manufacturing plant, they bring the cloud all the way down to the business premises. So it will be a more fluid world where the edge computer is sitting at various different locations. I think we talked at length about the IoT piece. You got the feel for that. The AI, I would describe it as two things that I see is going on. First, the part of what's going on the application side, how we use AI to get more meaningful information out of stuff that's going on. But we also apply AI in the network and how the network is run, so that we can automate and automate and automate, because eventually we cannot do all these different things that we're talking about here with manually setting up and tearing down things in the network. It has to be automated, has to be more or less where the network starting feeling, hey, it's running out of capacity here. There's a lot of people now watching a Tanmay show here. Perhaps we should bump up the capacity down to his place, otherwise people won't be able to watch this. And then I think the last bit of this is like the augmented and virtual reality today. I guess most people don't realize that AR and VR consume 10 times as much capacity in the network as a standard or an HD TV stream. So the moment you start using those kind of technologies, you have totally different requirements on the network, both from a performance and the latency perspective. So there's a reason why those type of devices today are tied with a wire to a desktop computer near to you. And if you make them mobile, you go out with two backpacks. You take your ski goggles, you put the backpack with the desktop, another backpack with the car battery, and then you go out and about. What if we could get rid of that backpack with the desktop computer and put that in the edge, and the battery, put that in the edge, and starting making these goggles so that they're light, almost like the goggles I have on me. Because this is the super exciting part of 5G that I'm thrilled about. Think about it, like I'm the generation that read manuals. My daughter often say it takes her half an hour to find the manual, another half an hour to figure out something useful in it. And she says, well, why don't you just do YouTube? Just check it out and see what's going on, and you learn it instantly. Fast forward a little bit here. Her daughter's going to laugh at her, say, Mom, YouTube is so old school, watching old people have done stuff ages ago. Why do you just put on your glasses? You say, can I get instructions, please, for Swedish meatballs? And you're standing there cooking, you're getting all the instructions in front of you, seeing that, yeah, that's right kind of beef, that's right, yeah, you got the egg there, good. And you get these instructions and helping them in real time. And that is perhaps the most fascinating application that I see for 5G that we're going to unlock in the future. So all of these are kind of interrelated to each other.
Right. So all these different use cases, they're sort of tying into each other, right? I feel like that's what's that's so incredible. Is it's not just each one sort of isolated there on their own. I feel like they all sort of tie into each other. Right? What you said about AI and machine learning, and sort of what I also mentioned about the cloud becoming closer to the edge in the sense that now we don't necessarily need to be loading GPUs with you right beside where you're physically located. You don't have a desktop computer on your backpack for VR. Now you can actually access the cloud and that wonderful compute that we have, from pretty much anywhere instantaneously, with low latency, with high speed. And one more thing that I really appreciate is that this also ties into just how much of an infrastructural field I think machine learning really is, in the sense that not only is 5G enabling better machine learning to happen, but machine learning is enabling the 5G network to do what it does, right? I love that example of, being able to intelligently route more capacity or bandwidth to wherever it's most needed, because I feel like that's a wonderful example of where machine learning shines, right? Not only can we actually use it in different fields to enable that field or that use case to be better, but that can then be used to help us with machine learning, right? That's sort of what ties into the exponential innovation that we've got going as humans, is that everything we invent helps something else in some other way, and I feel like that just ties in such a nice way. Another thing that I really like, and maybe a good analogy, would be Tesla cars, actually. Because if you think about Tesla, I mean, there are two things that I really, really appreciate about their cars. One of them is, of course, the fact that there's autopilot. I mean, obviously, that's my favorite feature, as you can tell with machine learning. But apart from that, it's also the fact that it's a car that updates itself. It's not like, every single year you've got this car, you buy it, and that's what you're rolling with for the next few years. You buy it, and the very next day, there could be an update that significantly improves your driving experience just because that software is better, right? And so to think that 5G finally is also sort of catching up in terms of mobile network and is now able to update and sort of roll and change over time, I think that's really exciting, because now we have this opportunity to be able to deploy infrastructure, but have it change and have it evolve over time, just like what Tesla is doing with cars, right? So when you buy the car, you're actually almost buying it with the future promise of this may even just appreciate in value if tomorrow there's a software update that enables full self-driving, right? So there's so much there that I think is so much more modern, and I think that's something we should definitely get into. But first, I do want to quickly ask another question from the live chat. This one's from Thierry. And he is saying, what do you anticipate the role, vision, and impact of 5G on IoT solutions? And what class of solutions do you think will grow?
I think that it will have, I think it's for the impact that 5G will have on IoT, essentially, that we can make it a little bit more granular. Because today, if you look at, it's fairly straightforward to a smartwatch based on the technology that we have for 4G today. But the world of IoT is moving in two different directions around this, both down and upwards. So you have a whole field of application of IoT, where the amount of data is not critical, where other things are important. Like if you start putting out sensors in a field and start measuring the moisture in the soil as an enabler for tracking how much extra water should we put on here, like which could be critical in a vineyard. Those kind of moisture sensors sends very little data, but you need a lot of them. So it's not that you couldn't put out like a $400. If those sensors were $400, you couldn't put out them as frequent as it needed. So there's one movement which is enabled by 5G or technically even by the evolution of 4G, which we call narrowband IoT or Cat-M1, which is essentially allowing you to provide devices, drive down the cost, but still connecting them over the wide area network. So it's typically things that are outdoors in one way or another. And so, and those devices, they're perhaps like, if you would see what dollars, even below $1 a month, very little traffic, very little power consumption. So perhaps you want those sensors the power consumption should be years rather than a day or two. So you got that whole development that's going on the small and the little and the tiny piece of IoT sensor based. Typically see this being discussed in the industry as massive IoT or massive machine type communication, because it's mostly machines that communicate to other machines. If you then move upwards, you're talking about critical IoT. Critical IoT is applications that are sensitive in performance in three different ways. The power or the performance and the speed in the network, the latency, so that doesn't take too long for the data to get to the destination, and the availability and reliability. Give you an example in that category. Talk about a little bit about starting wildfires. It's typically when a power line falls to the ground and hits the ground, dry grass, with tons of power going through that line. That's enough to kick off a pretty significant wildfire. What if you could say that, hey, you have a sensor there and say, hey, this lines have fallen off, and before it hits the ground, that you send the signal back to the station, cut off all the power, because this line is soon going to hit the ground. So by the time the wire gets to the ground, you've switched off all the power. Or we're talking about a robot today sitting in a manufacturing environment. You have the robot, which all the physical part of the robot, the physical part of the product, then you have a lot of compute resource and capabilities on it. Today, as the compute demand grows, so when you run out of compute, you typically have to change the whole robot instead of relying on that compute next to it, so that you can have independent lifetimes for the compute portion of the robot and the physical portion of the robot. And a lot of that one require extremely low latency between the robot and the cloud compute. We look, for example, at how you're milling jet engines, like this gigantic discs that are in a jet engine. They take around 24 to 30 hours to mill. And you cannot have a single thing that goes wrong during that milling process. As soon as you got a vibration, that's like, okay, that crashed that whole disc. So they've typically been struggling with, hey, how do we get up the yield? We have to throw away every fourth, every fifth of these gigantic blade discs. And if you think about what that is, it's huge, 10 feet across at least. And milling and working with those kind of applications, compared to if we then have, say, hey, we're starting to see vibration, and within a millisecond or two, you are either making corrective adjustments or things like that. So it's those kind of applications. So the industrial IoT applications, which are more in the performance and in that category.
I'm trying to think of a good analogy here, and I think one of the best ones that I can come up with right now is when it comes to sort of especially the latency aspect that you talked about. And I love the example of the power line. Before the power line hits the ground, you can use networking technology to automatically say, this power line is about to fall, let's quickly shut off the power. Maybe a good sort of analogy as to why that's important. I mean, we're going back to sort of something that's a little bit different. It's about computing power. But I believe one of the original team members that was building the very first iPad actually threatened to quit Apple if they used Intel chips instead of building their own custom processors. And the reason for that was actually very simple. Because in order to drive that high resolution display on a mobile device like an iPad, they needed the compute power from a custom chip to be able to do that. And so with that custom technology infrastructure came that ability to run a high resolution display on a mobile device. And now with 5G networking technology, we have this capability of being able to not just send a massive amount of data really quickly, but just being able to send, individual signals really, really quickly from one point to another. That again enables these kinds of applications and is going to be so great for IoT. So I like that answer. Thank you very much for that. And actually, there's a question from Akash that I was about to ask you. What I feel like is really important is making sure that technology is accessible, right? And making sure that especially technology like 5G, which is literally meant to connect people across the world, is something that everybody actually has access to. So my question was, how is access to 5G going to differ across different geographical areas? What kinds of 5G are different people going to have access to depending on where they live? But Akash is asking even more generally, technology is useless if it's not sustainable and accessible to everybody. So how are we going to ensure that 5G is going to be accessible to everybody and is not going to be one of those technologies that only a couple of people actually have access to?
So I think this is perhaps one of the most debated questions in the industry right now regarding coverage and access to 5G and how it's going to develop. One of the reasons why it is difficult for everybody to get their arms around this is that 4G, when we built up 4G, we pretty much built the network first. We built and built and built and built and built, and then we switched it on. So when it comes to 4G capacity, I think most people view it like sunlight. They just expect it to be everywhere. And they also expect it to go through windows and even walls to get on the inside whenever it's on the outside. So that have made us for pretty much for a whole decade, we haven't really thought about it. We just taken it for granted. Of course, there's spots where there's not good 4G coverage and stuff like that. But for the large majority of people, the 4G is pretty much everywhere. And then the workarounds for the places where it isn't. When it comes to 5G, as I alluded to earlier, since there's a couple of different ways to do 5G, we're expanding 5G in more ways. So 5G in dense urban areas might use something that's called high band or millimeter wave technology, reach short, but provide very large amount of capacity in very small areas. And that is where you have a lot of people. I typically say that well, I'll come back to that. So that is one piece. The other one is essentially about providing capacity across the whole metropolitan area. So increasing the total available capacity that's available for consumption, and in a kind of a more uniform way across the metropolitan areas or along interstate highways and so on, where there are also a lot of people. That's where we typically have the mid-band technology. And then low band is essentially where we have taken the spectrum that we use for 1G and 2G services and for TV services. We've reformed that spectrum and using it now for 5G services. That is when you get out in the rural areas, or if we're going to look at, well, what is the best technology to cover farms with? Not just farmers, but the farmland. We're looking at those kind of technology. So I think you can say that this 5G will eventually be everywhere. You can get an idea of which type of 5G you can expect by looking at how many lanes there are on the road where you are. If there are 3-4 lanes on the road, okay, then it's high band and that type of technology. If there's 2 lanes on the road, then it's more mid-band territory. If there's just 1 lane on the road, well, then it's perhaps low-band territory. But it's not really a big problem because in areas where there's 1 lane on the road, there's typically less people traveling that compared to the areas that there are 4 lanes on the road. The thing that requires attention, though, in my view, is you have 2 very interesting development that's going on top of this, which is society related. We talk about the smart cities and the smart city enabling that and requiring 5G in the city and so on. And that tend to all market forces tend to drive towards that problem, so we don't forget about that problem. There's very little risk that someone will forget to build 5G in a large city with a lot of people. They will do it because there's opportunity, and also they'll do it. If they don't do it, they'll be totally congested 4G networks. So you got that element. But then there is the sibling, which I often talk about as a clever countryside, that in rural areas, we need more focus on making sure that we are not left behind here in the rural areas. A little bit like my hometown where I grew up, where you have to approach it perhaps from a different angle. I think it's important when we talk about broadband in those areas, not only talking about what it does for consumers in rural areas. Equally important, what does it do for businesses? And there's certain businesses that are rural that never will move into town. Farming will never move into town. Outdoor recreation will not move into town. Green energy production, windmills, that will never move into town either. So we need to make sure that we pinpoint those kind of businesses and see what we can do for them. And then when we add vital society function, I'm thinking about education and healthcare. We need to put a wrapper on all these things and say, hey, this is our clever countryside. We want our community to be a clever countryside. So we also can attract people from the cities to move out, and saying that the pandemic has showed you can work from anywhere in a digital profession as long as you got broadband. So if you have the vision to actually bring those things out, a little bit going back to my hometown, in the house next to where I live was a guy called Smokey. He was the guy behind the racetrack. It's like you would be considered, even any era, you would consider totally crazy if you build a racetrack in a town with 5,000 people, especially if you tell you're going to run Formula One. But that was a guy with a vision and also the ability to drive things through. So I think we need a 5G Smokey in each and every small community, someone that can carry and drive and create the passion and the interest for this, so that you're not saying, well, everybody could get 5G, but it will not come by itself. So I think that is perhaps the most important development that we have here in the United States over the next decade here, to making sure that don't think that, well, 4G is good enough for us. It's like, it's like, okay, I should never buy a new car. I'm fine with used cars all the time. Well, it can be 10 years behind on technology. It doesn't really matter. It does matter going forward here. So, well, I can talk forever about this if you hear, but I think this is some of my points and thoughts.
Gotta say, I love the example about the 5G Smoky. I feel like that is actually important because, there's again, actually, if we go back to your point about there's some businesses, some industries that fundamentally must stay or are rooted in rural areas, right? Things like farming and green energy production and things like this. They're going to be done in rural areas. And so we need to make sure that they actually have the 5G connectivity in order to actually gain the advantages of that technology. Otherwise, why are we building it, right? If the entire point is that now we can bring the cloud closer to the edge, and now, for example, farmers can actually have, more intelligent farmland with IoT technology, being able to access the cloud, use AI machine learning capabilities. If the 5G network isn't there, then, that's just a use case that could be great in theory, but won't actually work in practice. So I feel
I think one point here is that there was a gentleman here that described this to me, and which was the real eye-opener for me. He said, I don't know exactly how the technology works, but when I hear people talking about it, I envision 5G as being the 21st century farm roads that can connect the economy in the rural areas to the big cities. And if you think about farm roads and why we build farm roads, it's not necessarily that the farmer should be able to go into town and shop on the weekends, but it's for the towns and the cities to be able to get all like food coming in. And that's so I think sometimes you need to look at the problem from the different angle to see what is really going on here. But I think saying no to 5G in terms of like and being outside of the digital economy, I think is a very, very bad thing too.
I completely agree, right? Everybody needs to be connected to the digital economy. If farm roads are going to connect them to the physical economy, we got to make sure that they have 5G to be connected to the digital economy. I feel like that's absolutely critical. Now, again, lots of questions from the live stream, but something that I quickly want to ask you before we get to more questions is about marketing in specific, because I know that's your sort of, field of, or that's where you focus when it comes to 5G technology. And I know personally, even based off some of the questions that are coming in, that marketing 5G can sometimes be a bit of a challenge because, well, as you mentioned, there are lots of different quirks, right? One of them being that it's, marketed towards both businesses and consumers because there's this, broad spectrum of different things that 5G can do, all the way from, sort of higher frequencies, lower frequencies, all sorts of things. So it's a bit more difficult to market 5G technology. At least that's what my hypothesis is. Can you maybe tell me a bit more about those quirks when it comes to sort of marketing 5G technology? What can you say? What can't you say? What are some of the common misconceptions that people are getting? And specifically, what I'm interested in, what are some of the ways that 5G is misrepresented in marketing material?
Yeah, so I think this is a it's a huge subject in itself, but I'll focus on describing a few things here. I think the first things that is that when we look at the role of the network, the notion that some people say that the devices are smart and the applications are smart and whatever is in between we don't really need to care about. That I think that narrative has gone a couple of that record has been played too many times on the record player. Because the connectivity in between is absolutely fundamental for the other two things to even exist and work. We've seen that right now during the pandemic, that saying what it meant, like the difference from our case, for example, having 3,000 people that are in the office working every day compared to we just turn it off, and then now 3,000 people are spread out all over town and are supposed to do the same job. I think that there is certain things that is in the DNA for broadband, that you can do most of the things with it. But I think that the new thing that's going to come for consumers, I think there's going to be a lot more focus on the experiences that 5G is creating, and experiences in certain settings. I go to a Formula One race, like 50,000, 100,000 people can't share a single thing because the network is totally congested. Would I pay $10 extra per race when I'm there for a week and for 3 days? Would I even pay $30, $10 a day? There's certain things when you can tie a big value of 5G to something that is another big portion, a big bucket of money, where you add a fraction to it. The other thing I'm thinking about is universities. Everybody say, yeah, students don't have any money. The average student in the United States, they pay $26,120 a year in tuition fees. What if we added $10 a month to that? Would people get crazy and say, I'm not going to go to college if it costs $26,240? Or if we could take that to, like, with $10 a month, you could unlock so much innovation potential at the university. So I think it's a little bit here trying to find what are the experience, what are the things we can make a difference, and how can we pay for those things. So I think there's a lot to happen. If you look at the whole business sector, like the big challenge there is the interfaces has been very much about the discussion between a service provider and a business. They say, how many phones do you have? Yeah, we've got 7,000 phones. Okay, so how big data buckets do you need? Do you need 7 gig or do you need 8 gig? And then just write it in agreement on that for the amount of phones that you're going to serving. Now, those conversations are totally different. And like when you're going to go in and describe, hey, your company is so-and-so, what can we do with 5G? Well, I don't know. It's not only about the bucket and a dollar for the bucket conversation. It is so much more profound. I spent the last 2 years traveling and meeting service providers and their customers, and started to see a lot of very relevant, interesting questions. And so I worked with one thing earlier this year. We described it as a practitioner's guide for 5G to business. And what it was that I started to feel that a lot of these challenges were a little bit like what anyone that had gone to college faced, that you've done something that you were really, really good at, and then you're going to go into college and you don't really know what that is. You think it's like perhaps a bigger step and a little bit tougher than anything I've done in the past. And so what can I do to prepare? Well, you can go through this little summer school. Like I got the binder with 200 pages before I started and say, hey, this is stuff you should work through so you get better prepared to the next step. So I see for the whole business sector, we're a little bit in that in between. I knew what I did, I knew it perfectly well, and I'm going to dive into 5G. I don't know what it is. I need to do the summer school so I get well prepared. And then 5G is not like before and after, like you go in the elevator and push 5 and you get there. It's more kind of a thing that goes on in the stairs. You learn, do, learn, do, learn, do. Mm-hmm. So it's more about thinking about 5G and the interaction of 5G. It's more like a college degree, 5 years, a lot of stuff going on. You have to start with the easier things and then get to the harder things at the back end. It's more that kind of a journey. And looking at it from a marketing perspective, what I do is not so much marketing to operators or service providers, what we have and what we can do for them. It's a lot more going out with them and helping to see, okay, you're doing this with that guy. Okay, this is perhaps more like this. So it's more like more co-marketing, more co-creation, a lot more collaboration that's going on. So it's that journey in itself is as steep as the 5G journey to be on that train.
One thing that I will say actually is you reminded me of, again, another episode that we had with someone that was in the field of marketing, and I believe she was talking about how it's really important that as a marketer today with today's technology solutions, it's important that you actually collaborate with the person that you're marketing to, and almost sort of blur the lines a little bit between marketing and consulting in a way, because the way that modern technology works isn't just, all right, we're going to take 5G or we're going to take AI and we're going to deliver this solution to you and it's going to provide X benefit because you have this exact use case. Technology is becoming more and more specific and personalized. I feel like an organization, I mean, just like with AI, they can't say, now we are an AI-powered organization. You can't just say that, right? You can't just do that once and be done with it. It's a continuous process where you continue to identify bottlenecks or places where you have data that you're not analyzing, so on and so forth, and continue to apply this technology. I think I really agree with you in the sense that 5G is similar. You can't just say, we're powered by 5G now, or we leverage 5G tech now. You have to be able to say that we are on this sort of evolution of taking specific use cases where 5G can be beneficial to us, or even inventing new applications to solve problems that we have using the power of 5G, right? It's not just one thing, it's a continuous process, an evolution that happens over time. So I really like what you mentioned there. Now, actually, there's a very interesting question because we talked a little bit about this sort of 5G technology from the business angle, and of course there are a couple of people joining the stream that are talking about the sort of consumer angle. And specifically, Shiva is asking us, what are some of the challenges that just the everyday sort of average person might face with accepting technology like 5G? So what do you think some of the challenges are going to be for consumers as they accept 5G tech?
No, so I think one of the challenges is there's a couple of different challenges. And it's challenges that different groups of people have. For my mom, for example, it was really hard to get on terms with an iPad or a smartphone and not having like these gigantic buttons where you can make phone calls. But now the primary way we communicate is WhatsApp. You go to the other spectrum. When my daughter, when she was young, she always said that, hey, it's time to upgrade now, Dad. I'm ready to move on from an iPad to a laptop because laptops is more for grown-ups and iPads for really, really young kids. So you have like a whole continuum of a challenge. What I think is going to happen is that typically you have three things that are working in tandem here. That you need networks, you need devices, and you need applications that run these devices. So in the past, we have typically, okay, like this feeling that we should have a break here. So we typically have had a world where the networks came first, and then the devices came, and then come the applications. So there's three things going on here, and they don't really know if the other is going to take off. So the network guys, they say, hey, I hope that will devices and application, but I know that I have to start first investing in the network. Then you have the device guys and say, hey, we know that the business case for our devices, that will be good if we know that there are networks out there. And then the applications are typically coming after devices and applications, after devices and networks. What we have with 5G is most likely going to be slightly different. There's so much momentum right now in the ecosystem, so devices are coming to market a lot earlier in the cycles. If you look at the iPhone right now, so it's an example. The first iPhone for 4G came 33 months into the deployment cycles of networks, and it came one phone. It took 3 years to get to 4 phones. Now you get 4 phones 22 months into the cycle. So we have a very vibrant ecosystem on the device side right now that there's no one that is saying, hey, I'm betting that 5G will not happen. Everybody's trying to be there first and getting out. So right now you're having large number of phones. We're projecting 48 million in North America just here by the end of next year. So you get large number of devices happening early on, and which then could expose it to, okay, are there really applications that I can use? Are there really network built out where I expect it to be? So I think that will be a little bit the challenge that we're gonna face here, and seeing in which order when do all these three wheels cog into each other now for 5G? I think it will happen pretty quick, because the devices are out there, early adopter coming first. If people bought a 5G phone, they're gonna say, hey, I expect the networks to be there, at least for some of the key places where I'm. And right now, when you see the strong momentum on the device side, that we're going to drive applications. Slightly different on the industry side, because there we have, it's more application knowledge that you need to get into when you build the things. So that there's typically working with an industry anchor, a car manufacturer, or a power utility, or warehouse giant, or someone like that, to trying to hash out and nail the use cases. So I think there will be a phase here which should be a little bit nail first and then scale. And everybody's like, so they've heard so much about 5G, so expect everything to be there. Like, hey, did the sun gone up yet, or is it still down? Mm-hmm. So I think there's a little bit of risk that we're expecting everything to happen overnight, when it's not really going to be like that.
Interesting. But it's nice to see, though, that everybody's sort of jumping to be an early adopter of this technology. I mean, I love the example you gave about the iPhones. I feel like, especially within the sort of consumer field, and when it comes to phones in specific, people are upgrading phones less often. Nowadays people are like, oh, my phone's good enough. They'll keep it for much longer than they would, in previous generations. So I feel like companies like Apple are almost forced in a way to start to adopt 5G and other new technologies now, because people are keeping their phones for long enough that in the future, when 5G networks are even more prevalent and actually available to us, we want today's phones to be able to handle that future, and people are already sort of looking at that today. So if Apple doesn't release a 5G phone today, that's definitely a reason that someone else would say, hey, I want to go buy another company's phone because they're going to have 5G, and in the future, I want to be able to use that technology, right? So there's a lot of stuff going on behind that, and I feel like for consumers, there's going to be a lot of advantages. Of course, there are going to be some challenges, just like there always are with any technology, but I feel like in the end, it's going to enable all sorts of new experiences that we couldn't have imagined without it, and it's going to be really good. Now, there are a couple of questions, and these are the ones that I was sort of almost expecting. And these are about the sort of, I would say, well, again, I want to sort of leave this up to you, Peter, but almost the misinformation about 5G technology that's been sort of spread out around the internet and so on, as to how 5G, is harmful to different animals or birds or humans, and people are asking, what are your thoughts on millimeter waves, and is that harmful to us? Can we talk a little bit about that for a minute? Has there been any real evidence that 5G is actually harmful?
So I think that this is a highly relevant question, and I think there's a lot of people are concerned about it. And I think that if I go back and see all the kind of reports that have been written over the years in terms of this, and say, is this harmful? Is that what is harmful and not harmful radio waves? I think that there's been a very, very solid job in terms of understanding about the technology that it's not harmful. I think that the challenge is that it's often described in a language which is hard for people that don't know technology to understand what it really means. So I think there is a remaining job to do to actually make it easier for everybody to understand and so on. There's always been this debate regarding the towers for all generations. When 3G towers were introduced, since they were a little bit higher bandwidth, you needed higher towers, which more or less generated riots in every single neighborhood. So, we don't want the high towers. And with concerns about that was more from the appeal of those towers. When we look at millimeter wave, I think that a lot of people think it's like you're exposed that if you put your head into the microwave oven and turned it on. So there's a lot of these things, like when you're looking at these technologies, that the reason why they reach so short distances is so we have adjusted or reducing power levels which are so low to not be harmful. So a lot of these things, like when you're looking at specific millimeter wave, theoretically, I guess we could use it from a tower and just over long distances, but then we will be at a lot higher levels, especially from also when you're sending it from the levels going from your phone to the tower, which when you're holding your phone next to you. So I don't see any reasons to be concerned, but I think it's a job for the 5G Smokey to do whenever he is talking about 5G in the community and neighborhood, also have this topic on the agenda so that everybody feels comfortable with it. Mm-hmm. Because it's not very different from the previous technology generations, and at least that we were seeing on the mobile side.
Right. I feel like with a lot of technologies, 5G included, of course, it's just the fact that the technologists that actually know about the technology and the people that actually understand that it's not harmful and that it's, and that there's this sort of misinformation, the terminology that they use to actually describe this and to say that it's not harmful is terminology that can very easily be twisted and misunderstood by people that want to spread that misinformation, right? If we say millimeter waves and, high frequency electromagnetic waves, and, when we use all this jargon, people that don't understand it can easily be misled to think that it's harmful in some way, even though it isn't really. And of course, everything is definitely debatable. There's a lot of research to be done into this sort of thing, but as far as we know right now, from all these different studies that have been done, 5G isn't harmful. I mean, precisely to your point, Peter, it's built to a standard where even, for example, millimeter waves are acceptable because of the power levels the low power levels that we're at. So I will say that's definitely something you can take a look into, but I gotta say that across fields, whether it's AI, machine learning, or 5G, we've got to start actually simplifying the reasons for why technology is something that we should not be afraid of, right? When AI, it's, artificial intelligence is going to replace humans, and AI is going to become, super intelligent and all these sorts of things. And with 5G, it's harmful to people and animals, and so we got to somehow figure out ways to make that information more accessible to people so that they actually understand what it is and isn't capable of. So thank you for that.
I think one other point on this one is that there's also a lot of attention have gone into the industry actually making sure that 5G is a sustainable technology from environmental impact. So if you look at all previous generations, since we're increasing the spectrum, that we use for as one of the ways to get more capacity in the network. That spectrum is powered by electricity all the time, and for previously we've seen like the energy consumption in network went down from 2G to 3G, went up from 3G to 4G. But right now it's moved from 4G to 5G. We're going to get significant leaps forward in performance. But we're also looking at saying, how can we break the energy curve? What can we do for smart things in how we turn on and turn off things that consumes power in the network in a way so we can break the energy curve? So even with a significant increase in traffic, we're talking about 10x over a decade, or 10 to 20x over a decade, that we can keep the power consumption flat or even slightly reduce it. That, I think, is perhaps one of the most remarkable things about 5G that we don't talk about. So trying to do this with 4G technology and achieving this capacity growth will going to drive incremental energy consumption, versus with 5G we have ways to actually working very hard with ways to actually to change that curve.
Precisely. Right? We got to think about the fact that 5G was fundamentally designed to be scalable, right? 5G was designed to be able to say, in the future when we have all this demand, how can we make sure that power levels don't need to be increased? I feel like that's definitely important. Quick question, actually. Maybe we can just do this one quickly as a bit of a sort of detour on a similar topic. Saisley is asking, why is 5G banned in other countries? Really quickly, as far as I know, 5G isn't banned. It's just some equipment from companies like Huawei, but continue.
So 5G is not banned in any countries. The deployment of 5G go at different pace in different countries because you are dependent on spectrum, and 5G use a lot of new spectrum. So spectrum is lanes in the airs that you and I don't see. So what typically happens is there's a frequency auction. You get access to that spectrum. Those frequency auctions in different types of band take place at different time. And then there's also a debate like which vendors will be approved vendors in different countries regarding, okay, do we want to work with these companies or those companies? So there is a geopolitical dimension on those considerations. And the reason why that is taking place is that 5G is considered so different, such important infrastructure in society. So if like 4G went down, you ended up on the front page on Wall Street Journal. But when 5G goes down, your economy is most likely stopping. And that's why there's that much attention paid to these kind of issues.
That's an interesting world to think about, where the network is fundamentally sort of the backbone of the digital economy itself. I mean, it already kind of is, but it actually already is. But to think that 5G is something that's so critical, something that has to be deployed with such careful consideration as to be so reliable and so sort of robust is definitely really interesting. Which is, again, back to your point as to why it was designed for such scalability. Another question that we're getting from Gopi, he's asking, what's your opinion on the following? First of all, and he asked two questions. One of them is, what are things that we need to be done in REL number 18? I'm not exactly sure what that means. Maybe you do, Peter. REL number 18, and later for smoother transition for expectations to 6G.
Okay, so I think this question is about release 18 of the standard. So that is like we have for the standardization of 5G networks is actually happening in something that's called 3GPP. So the organization has been around for 20 years. So what we typically do, we standardize we standardize the capabilities in a 5G network in a joint global forum. We currently released 15 was when 5G was introduced, 16 and 17 is upgrading it. So I think that you can describe the evolution and the things that's happening towards release 18 is that we're looking at both how we're introducing new capabilities on the horizontal platform level, and then we're looking at specifically introducing what we need to do for certain industry verticals. So what's required for industry, like 16 and 17, there's been a lot of focus on industry, on manufacturing and industry automation. So in these different, you're going to describe the focus for the standardization is targeting some of the key verticals and actually seeing what we're going to happen there. If we look at where we're moving towards 6G, I think one of these generation typically have happen every 10 years. So 6G is typically something, and you start working with setting directions and so on roughly 10 years before they come to market. So the 6G is not, it's like it's under the researchers tables right now. And I think we recently published a paper which is called the 7 Technology Trends 2020, which you can describe as putting 7 different continents of the world of the future network and describing where it is going. So it's perhaps it's another podcast to talk through what those 7 different things are. But if you're interested in that one, that is a really good paper. But it's also of the nature, it's like you're placing 7 big continents on a big globe. And then you're trying to figure out what's going on within each continent. So it's more about second direction, about important topics and conversation areas to penetrate, rather than, hey, this is how you do 6G.
Precisely. All right. Thank you for answering again. Unfortunately, I'm not very familiar with this whole like 3GPP stuff, but thank you for answering that. And Gopi, hopefully that was helpful for you. But there is one more question from him. He's asking, what is, according to you, the dark horse, so new things like IAB or NTN, and what will be impactful 5 years down the line?
So it's essentially which are the different capabilities and functions and features in the network. I think I would describe it like this. Right now, we're talking about a lot of different features and capabilities that are helping my seamless integration or integration between 4G and 5G, and also the fact that we use multiple different spectrum bands. So we're talking about spectrum sharing, which allow you to do 4G and 5G in the same spectrum. So not hard locking a piece of spectrum for 4G or 5G. I describe this as like, that's when you can combine the bus lane and the diamond lane in the same lane, and where the pane changes dynamically during the day. So that's the spectrum sharing. Then you're having carrier aggregation. Carrier aggregation, which is essentially saying you can take a little bit of high band, a little bit of mid band, a little bit of low band, and put them all together. So this is essentially about you taking capacity and capability from the different band and stitch them together into one broad swath of capacity that can flow seamlessly across over these different bands. So a lot of these kind of capabilities is where we're focusing right now. The thing that the capabilities that are important for the next step and what kind of the medium is like release 16 and 17 capabilities. A lot of it related to the time-sensitive networking, how we get the increased reliability even further. But it's not only creating more and more of these technology components. It's essentially thinking, how do we tie them together into suitable packages? I think that one of the absolutely biggest things that we haven't talked about yet here is about network slicing. The fact that you can take the available capacity in the network, you can divide it for different purposes, making sure so like your file sharing don't get with first responders out on an important mission. Like the fact that we can carve up the network in capabilities and assign different capabilities for each of those different slices based on where the function is located and what it's designed for. So that I would say is one of the biggest things that I see, which would be a game changer. And that right now with the work going on in release 16 and 17, that ties together the network slicing capabilities between the core, the transport, and the radio. So it goes all the way from essentially where we think the edge will be in the future out to the devices at the end.
You know, I gotta say, personally, there's so much that I'm learning about the world of 5G on this episode because, you know, on the surface, you don't really see all of the thoughts going into all these different features to enable not just a better network, but a next generation network. So I gotta say, I really have an appreciation for just how much sort of work and thought is going into this industry. Now, another question from Prabhakar, actually, related to, once again, what it is that we're talking about. Should I hold off on my 4G deployment until the release of 5G?
Could you repeat that one? Should I hold off my 4G
Deployment
deployment?
until
No.
the release of 5G.
So I think that the way to approach that one is this. You have three different technologies out and about now that people have talked about. 4G, proven, it's been out there for 10 years. 5G coming to market. Wi-Fi 6 coming to the market. And you have got all kinds of discussion going on. Should I skip 4 and 5, go straight to 6, because 6 must be more than 4 and 5? Or should I do 4 and 5 plus 5, because that's 9, so that is more than 6? So I think you need to dive a little bit deeper, depending on a little bit what you're trying to do. I think it's relevant if we look at 4G and 5G, for example. 4G, in the previous generation, it was more kind of, we went from 2 to 3, and went from 3 to 4. And in some countries, like 2G and 3G is about being shut down. If we look at forward, I would consider 4G and 5G to be two parallel tracks for the near future. The reason for that is a lot of the development that's taking place on 4G is actually for the massive and broadband IoT applications, and those ones will kick into volumes, very, very high volumes in that area. So I see more a coexistence between 4 and 5 rather than moving from 4 to 5.
Mm-hmm. I gotta say, when it comes to technology, I feel like a lot of us, have that sort of drive of, should I be waiting for the next big thing, or should I, upgrade for the sake of upgrading? I feel like maybe a good sort of analogy to what you just mentioned is the new HomePod Mini that Apple released, the new HomePod Mini. It comes with a really, really old chip that shipped 6 or 7 iPhone generations ago. And, at first I thought immediately, the first time I heard that, I was like, why exactly? That chip barely supported Siri. Why are you putting that on a dedicated Siri speaker? And then I realized a little while later that, technically they don't need all that extra power on a HomePod Mini. All they need to do is drive the smart speaker, and all they need to do is be able to analyze, input from the mic and speak with text to speech. They don't need to do everything else that Siri would be doing on a phone. If they've got the U1 chip and everything's integrated, it works. And so I feel like maybe that's also something that we should keep in mind. Is it's not like 5G is just going to outright replace 4G LTE, right? It's a coexistence between the two technologies, each one being used for what they are meant for in specific.
All right. You're spot on, and I think this one is like, to anyone saying, well, why don't I just wait? That is a little bit like when you start in college, or say, well, why don't you just party around in the first year, and then I wait to study until we get to the second year. I think this is a learning journey, and you're going to learn a lot in each and every stage. For some situations, you can learn a lot by deploying 4G today, using 4G for what that is good, and evolve that with the evolution of 4G, and then adding 5G to making it even better or doing other things. So, for example, our smart factory here in Texas, which we just built for producing 5G radios, that has got both 4G and 5G. Because the 5G technology is good for certain things, the 4G for other things. So it's a combination of. It's like you say, hey, we're going to play a round of golf. Should I use 7-iron or wedge? It's like, it's quite good to have both those clubs.
Yeah.
Or should I have running shoes or bike if I'm going to do a triathlon? Yeah, you need both. It's that kind of a scenario.
Yeah, it's kind of like within neural networks. I mean, recently there was that whole innovation around the vision transformers, and now you can use transformers to analyze sort of images just as well as transformers can do natural language, and better than convolutional neural networks. And people are like, transformers are taking over. But, I feel like it's a very similar analogy. Just because transformers can do vision now doesn't mean everyone's only ever now going to use transformers for every task, whether it's natural language or vision or tabular data. That's not how this works, right? It's going to be, you have another tool in the toolbox, and when the situation calls for it, you're going to use that tool. But if the situation calls for a completely different tool, or maybe you don't need the immense power of a transformer, or maybe you do have a very specific computing power requirement, maybe you're using an FPGA that was programmed to work specifically for convolutional operations, then you're still going to use a convolutional network, right? So it's very much let's have this toolbox. 5G is another one in the toolbox. Where are we going to use each one? Goes back to my point of, if iOS is going to be switching between 5G, 4G, depending on what you need, that sort of proves that, it's a coexistence, right? It's not like we're saying, all right, let's get rid of 4G antennas on the phone. We don't need them anymore, right? That's not how this works. It is going to coexist. All right, so now one more question. This sort of relates to something we were talking about a little bit earlier in the stream about how 5G adds value and sort of the point of where exactly 5G is going to enable new kinds of businesses to exist. And specifically, Akash is asking, how is 5G going to contribute to education and healthcare, two fields in specific? What kinds of new capabilities will it unlock within those two fields?
Oh, this is great questions. And I think that if we look at what 5G can do for education, I think that right now we have seen with the pandemic, one of the biggest shortcomings has been here that saying, hey, we have fiber to schools, but that doesn't really help when you can't go to school. So I think one of the things that 5G can do is help closing the digital divide, both in rural areas, but also in urban areas for the people that do not have broadband. So one thing is handing out Chromebooks and giving students a Chromebook, but if they don't have broadband at home, it doesn't really help.
Yeah.
So we did some things up with the school up in Vermont this year. They say, hey, we send home people with Chromebooks, but now they're half of them coming back. We don't have broadband. So I think there's an opportunity here to leverage like pocket routers or fixed wireless terminals that you have in your pocket, actually to enable and connect every single student. And I think students are not connected, whether it's K-12 or whether it's college. This is the absolutely most worst form of digital divide we can think about. And I think what I see is also if we connect students and make sure that they're connected and they develop skills in how to learn in digital form while they're going from kindergarten up to 12, you're creating a totally different landscape for education after that. Because if you have all children being savvy and getting educated, and then saying, hey, I don't really want to move into town just to get a college degree. I could go there for 4 years and then hope sometimes come back, but most likely I'm going to get lost in that. So I think that if you get a good solid foundation with using digital education skills when you are from K to 12, that the more people that are living in the countryside will actually leverage this technology to go to college as well, staying where they like to live and where they plan to live and where they plan to spend their future, getting the college degree, because a lot of the professions, even out in the rural areas, will need this those kind of skills going forward. So I see the connectivity as being an enabler for education. I all think we will see new education forms. For example, during the pandemic right now, we built a manufacturing plant during the pandemic. The people that know how to produce the things that we're going to produce here, they're overseas in Europe. We've had the training of all the people in that factory with AR and VR from overseas. And this is just another form of education that allow education to spread more fluidly. When it comes to healthcare, I think that we've seen right now with the pandemic, perhaps education, healthcare, the two areas shifted very quick. And you typically have had two problems in healthcare. You've got the demand side, the people that need the healthcare, and you've got the provider side, the people that provides it. I think right now, and there's always been this, can we really do counseling sessions through a mobile phone? No, people should come in here to the office and we have to check them up and so on. Now we didn't have an option. The provider side say, hey, we'll go digital. We'll consult with people over phone, both for whether it's a dentist, perhaps not the dentist, but for general practitioners and for basic checkups, if you're concerned about if you've got COVID or not, and for more for mental health, that you have counseling and mental health, doing that with the phone. So I think that this whole pandemic accelerate this the digital transformation of both education and healthcare. And I see that, especially from the countryside, there's only good things going to come out of it.
Right. And when you mentioned digital transformation, that reminds me of the episode that I had with Mike Tibbs, who's now a director at Shelter Insurance, and we talked about how digital transformation for the sake of digital transformation doesn't mean anything, right? It's about that evolution, and it's about that how are you adding value with digital or with new technology capabilities. And I feel like 5G is a great example of that. A lot of people just think, hey, it's just improvement for the sake of improvement. Now I can do the same things but faster. But there's really just so much stuff, especially within fields that Akash mentioned, like healthcare and education, that we just couldn't have done before this. That is real value. It's not just digital transformation. It is an evolution. It is that sort of next generation that's going to add so much value to our lives. Now I see one more question from the live stream. We have this question from Vinay. He's asking, will fiber deployment patterns change when 5G is deployed?
Yeah, so the question here is, so will fiber deployment patterns change? So fiber, you can describe it as a couple of different things. You can describe when you have fiber and you deploy fiber all the way to home, to people's home. So you typically, that means a coverage related process, which is typically you get fiber into your neighborhood. And then you get fiber connections, which is then from whatever the street or the neighborhood hub all the way to your house and into your house. I think right now, if you look at North America specifically, we're around, we deploy around 1.5% of the households get fiber every year. And increase and growing at that pace. If we do it really fast, we perhaps could do 2% a year. So it will, and the further out you get on the grid, like you take the easiest household first, and the further and further out you get, the more it costs to deploy fiber typically. So I don't see a scenario where we build where everybody get fiber ever. But fiber plays a very important role in 5G because you typically want fiber to the 5G radio sites. So you build fiber to those points or very close to those points. And then you can feed it with 5G. So I see the largest potential for 5G, especially when we talk about fixed wireless, outside with the fiber footprint. I see potential to connecting small and medium businesses, not only the large business buildings and so on. Large business buildings typically have fiber deployed to them today. So that is not going to go away. We're not going to use 5G to displace that. We might have 5G for some backup lines in that scenario. But the big potential is going outside of where fiber has been deployed, and outside where it's like, even if you do it with 1.5% a year, it would take like 50, 60 years to get everybody fiber at that pace with a growing cost the further out you get. So I think 5G has a role to play there, both for mobile application and portion of the fixed.
All right, thank you very much. Now, I will say there is one last sort of theme of a couple of questions, and I kind of almost expected this sort of theme of questions. And this one specifically is from Yash. He's asking, what about satellite networking like Starlink?
Yeah.
Any thoughts on that?
So the satellite, there's typically, depending on how far out you get, satellites always being discussed. And there's been a number of different satellite systems like discussed, especially low orbit satellites. And there's actually standardization elements in the 3GPP standard right now for expanding 5G2 satellites. I think that the way, when I look at it, I've been looking at we've seen it, we've studied this at length. And what came out of this when we look at rural broadband, there's typically 4 different types of scenarios. You typically see towns, which is pretty much where the economy for broadband, there's fiber to those towns. And building fiber in the center of those towns is pretty much like building it in a city. So like building in a smaller town and building it in the suburban area of a city is not that very different. So that's where fiber is going. It becomes a little bit more challenging for fiber on the outskirts of those towns. So the further you get, like when you're typically cream skimming, the further out you get, typically run into, hey, fiber becomes too expensive here. And that's where with 5G or other technologies could play a role, actually, how to take the rim of the city. Typically, those rims, there's such a high concentration of people, so satellite not necessarily the best choice, because it's both about upstream and downstream traffic we're talking about. The third one is essentially along interstate highways. You see, fiber is very common along interstate highways. So interstate highways literally working like the rivers 1,000 years ago. That's where people were settling down, and all towns grew up along interstate highways and so on. So if you can tap into that fiber, and if that fiber is like 3 to 5 miles away from where your town and your city is, it's typically a very good thing to do. Tap into that. You can build some of them with fiber and others with fixed wireless. And then you got the pure rural areas. And the interesting thing when you look at rural areas, where you can say that, hey, that would be perfect for satellite when houses are so well separated. If you look at the applications that are coming into rural areas, and especially in farmland, and the whole development regarding precision agriculture, there is pretty advanced things that's going to fly around there, like drones covering your crop fields, and autonomous vehicles working with inch precision as they're driving around in the field and so on. So they need pretty advanced communication services as well. So I think satellite would definitely play a role for certain applications. But I think I seen that the field with the applications are pushing the demand for ground-based 5G to reach further than we've seen in the past.
Mm-hmm. I feel like there's definitely a lot of challenges with that whole sort of area of satellite networking. It's always been something that's been an interesting concept to me, but there's just so many trade-offs that have to be made, and of course it's different for every use case. Again, going back to what exactly we said a little while ago, it's another tool in the toolbox. There's some cases that could call for that specific kind of infrastructure, but I do sort of want to go back to your point again, where it's about those tools, and 5G technology in a way sort of works with, even going back to Vinay's question, with, for example, fiber deployment in order to make that kind of infrastructure more accessible. So hopefully that helps, Yash. And all right, we've again, those were some really, really interesting questions. I've personally learned a lot about the world of 5G because, once again, on the surface level, it kind of just seems like, as a consumer, all you see is, oh yeah, faster mobile internet access. Great. But then what you don't realize is that there's this whole new world of things that we can do now with this technology that we literally did not have the capability of doing before. Kind of like how machine learning has enabled us to do so many things that we take for granted now. Like, for example, Siri is going to talk to you in such a natural, human-like voice. That never could have been done without machine learning, right? You open up iOS, and you have the little smart stack widget that automatically predicts what it is that you want to see based off of what time of the day it is. Or you open up your camera and you take a picture, and you're using smart HDR in order to automatically detect someone's face and make sure that it's bright even if the sun's right behind them. There's so many things that we just take for granted because, of course, technology can do that today. Because a couple of years ago, some researchers at Google or the University of Toronto or something were building out these algorithms that we're now deploying everywhere. So I feel like 5G is in that similar phase where as a consumer you're like, great, next generation, why should we really care? But then you start to look into it a bit more, and there's just so much thought that went behind how to make this not just the next network, but the next generation network. And so I can't wait to see what sort of comes out of this and the new experiences that it enables. So thank you very much, Peter, for joining us today. But before you go, one more thing I want to ask of you is, from even these questions that we've got, that the TechLifeSkills audience is really diverse, right? So we've got students, we've got people from business, developers, all sorts of folks. If you had to share a closing message with them, what would that message be?
I think my closing message would be focused on three things. The first one is don't treat 5G just as the faster horse, or you might miss out the boat that the same people did 100 years ago. There's so much more to it. And if you didn't understand everything of what I talked about, I didn't expect that. But I'd like to understand you to understand one thing is about and. When we set out to do 5G, it's been to do about consumer and business. 5G is also about mobile applications and fixed wireless. 5G is also about when we move from public networks and private networks. It is when we move from universal use to universal and business critical and mission critical use. So we're expanding the capabilities of it. And so that is like that, and this is pretty much a central theme of what 5G can do. And the third element is that you've seen it here through the direction I'm very passionate about. I know that 5G is going to penetrate the cities, but let's not forget the clever countryside. Let's get in the little, like the visions on county level in the small communities about what this can do for consumers, what it can do for the rural businesses that never ever will move into town, but they will have to be part of the digital economy, and what it can do for healthcare and education. Y para todos ustedes que están hablando de español, es especialmente para mi hija Alexandra, este episodio de este programa fue hecho para ti y para que tú sabes tantito de lo que hago en mi trabajo. That was a little message from my daughter about why I hope that she have gotten out of this session.
All right, so thank you very much to your daughter. Unfortunately, I can't speak Spanish yet, so I don't exactly understand that, but here's the great part. YouTube will likely automatically detect that that's Spanish and translate the captions to English for me. So I'm going to look forward to that automatic machine learning powered translation. And I can't wait for this kind of technology to reach the edge as well, thanks to 5G. All right, so thank you very much, Peter, once again. It was absolutely great to have you on the show. I've learned so much about this world of 5G, and we're definitely going to be covering more about this in the future as well. So thank you very much, everyone, for joining the live stream as well. I really appreciate it. Once again, this series, Tech Life Skills, is held every Sunday in the morning at 11 a.m. Eastern Time. Do join us next week. We're going to be getting deeper into the world of data. And so thank you very much, Peter. Thank you, everyone, for joining. Goodbye.
Thank you very much, Tanmay. Pleasure to be here.
Thank you.